Okay, guys, this is a Fire app that we have created, and this is to demonstrate the different types of launch that a Fire app can have. So basically, if you see here, there are three types of launches. Okay, one is actually not used in the real world, which is launched without without an authorization. So which means that anybody can just go call the endpoint and get the data, which is not a real world scenario. But these two are the real world scenarios which is one is where uh, it's a standalone app. So you just the patient or the provider, whoever is the user of the app, just goes to the app, and authorization process starts from there. Okay, and one is the EHR simulator. So in this case, what happens is the app itself is is in the EHR. Okay, so like you open a patient chart, and then if you want to go to a specific, suppose that's a let's consider that if it's a patient with some heart condition, and somebody has created a Fire app for cardiology, uh, get reading all the patient's information and doing some predictive modeling on that. So in that case, it is the EHR simulator. Okay, now as we do not have a real EHR here, but Smart IT has given us a platform to simulate that, launching the Fire app from EHR. So let's see how it works. Okay, so when I click on EHR simulator, if you see, I am being redirected to launch.smarthealthit.org. Okay, now here what I need to do is I just need to put my app's launch URL. Okay, in my case, it is the app is hosted on it's on my local host, so it's localhost port 3000 and launch. So once I click on launch, okay, so understand, now I, as a doctor, okay, just imagine that this screen is my EHR screen. Okay, and this launch button is just my application icon. Okay, and here, instead of all the smart launcher and everything, I have patient's information. The patient's chart is opened in front of me. So I have I'm looking at his information, and then I say, hey, cardiology Fire app, okay, open, and then it opens. Okay, now in this case, it is going to take me to the authorization server. But in real world, it doesn't happen like that. The authorization happens behind the scene. I don't know why this, it may be because of my network. Let me try again. Okay, it's happening. Yeah, I am having some network issues. If you see, I almost do not have network. Okay. All right. So now here it is taking me to the EHR's login page. Okay. So this is like login with Google, login with Facebook. You must have seen it, right? Whenever, so that is called OAuth. Okay. And OAuth, we do it a lot. We use it in our real life a lot. A lot of applications and websites do have OAuth authorization feature, where we authenticate ourselves with our Google login or Facebook or Instagram. So in similar way, here, practitioner has to log in to their EHR screen. Okay, and I will tell you in detail what happens later, but let's go through the demo right now. Okay, so I log in as a practitioner, and now it shows me all the patients that I have access to. All right, so on this EHR page, let me select a patient. So basically, this is not actually what's going to happen, but I'm doing it manually. I'm selecting the patient manually. But remember, in the EHR, I've already selected the patient. So the context of the patient is automatically going to be passed. Okay, so let me select this patient, David Alcantar. Okay, so the authorization has been completed. Exchanging authorization code for access token. Okay, loading the dashboard. Now I have got information for David Alcantar. Okay, I've got his encounters. Okay, I've got his observations. got his medications, got his allergies. Okay. So this is how I get all the information about that patient in my FHIR app. Okay. Now I'm not in EHR anymore. Okay. I just launched the app from EHR. The EHR passed the patient context, which means the patient ID or their encounter, whatever. And then I was authorized by the EHR server. It gave me the access token to now access all the other resources. Okay, so that is how it works inside the EHR. Okay, now let's go back and let's see how a standalone launch with OAuth works. Okay, and at this case I've configured the Epic's FHIR server. Okay, their its authorization server. So as soon as I click on this, see what happens. So it takes me to fire.epic.com interconnect FHIR auth. Okay, API FHIR are for base URL. Now it's redirecting me to the authorization server. Okay, now you see this is a real epic hyperspace page, okay, where I'm going to log in. And if you see this FHIR2, this username and password, I've it's for a provider. I've got it from their FHIR's developer portal. Okay, so they have all the username and passwords mentioned there. So once I log in, now what's happening is this is a standalone launch. Okay, so first when I launch it, it knows that it has which authorization server it has to redirect me to. Okay, and it redirects me to that authorization server. Now I log in here. Now see what happens. Okay, it is okay. I'm still on the Epic page. Okay, it says confirm external access. Are you sure you want to grant OMAI FHIR app access to data on your behalf? I say grant access. Okay, now see what happens. So now I have got this patient, Sarah Jane Johnson. Okay, because that was the that is the patient's context that we passed after getting the authorization token. We use that authorization token to get the patient resources. Okay, now annual physical examination, see observations, blood pressure, allergies. She's allergic to penicillin. Okay, if you see medications, we have she's taking all these medications. Okay, now what we can do is, now this is a feature that I have built in this FHIR app. Okay, where now you have all the patient's information. Now you want to do some clinical analysis on that patient's entire information. Okay, so I just hit clinical analysis. I do start clinical analysis. Okay, this may take some time because so we have a model hosted on a runpod. Okay, I'm using uh so basically I was training a model. You can see it in my previous video. I've trained a llama model. So uh I'm using that model to do the clinical analysis. Okay, now the clinical analysis is done, and what it says is, let's see, executive summary. Sarah Jane Johnson is a 40-year-old female with well-managed type 2 diabetes mellitus, hypertension, and high cholesterol. Her recent lab results indicate good control over her condition, and she is adherent to her current medication regime. Key findings: HbA1c is at 5.8%, indicating good glycemic control. Blood pressure is well controlled. Okay, active conditions: diabetes 2 mellitus. Okay, immediate medical attention required for any allergic reactions, especially to penicillin. Okay, so it is saying that nothing else, but only she's allergic to penicillin. Uh, so immediate attention is required there. What else? Okay, it says diet recommendation: high fiber foods such as fruits, vegetables, and whole grain foods to avoid sugary foods and beverages, processed food high in sodium, saturated fats. Okay, meal planning, lifestyle recommendation: exercise, sleep, stress management. Other recommendations: is there any health risk and any prevention? Moderate risk from cardiovascular disease, complications from diabetes, low risk. So basically, what this model does is It takes that patient's entire medical history, okay, right from allergies to medications, everything that you see here, okay, and it does its clinical analysis on that, and it returns all this clinical summary and everything, okay. All right, now comes the important part. Now let's see how the authorization works, okay. So I already have a documentation here which I have created. So let's go through the OAuth flow, okay, how it works. So what happens is basically, okay, when user initiates a launch, okay, the app generates a random state parameter for security. State value is nothing but it is just basically to it's like a handshake. I will generate this and I will store it in my in the session. Okay, this can be any random UUID. Okay, and I will send it with the authorization. Okay, now when the authorization server redirects it back to my app, it will return the state. Okay, which will prove that it is indeed the response from the same server that the request was meant for. Okay, so just for security purpose. But what is PKC? It is again for security reason. Okay, uh, so that a hacker, you know, if he intercepts. So when you send a request to the authorization server, and authorization server is sending you is redirecting back to your app with the authorization code, because that authorization code is important. That is what you're going to use to get the token. Okay, and okay, so I'll explain you the entire flow, but remember this. So what verifier does is, verifier is any random string that my app generates, okay, and it stores it. Okay, the verifier is not sent when to the authorization server. What's sent is the the challenge. Okay, what the code challenge. So code challenge, what it means is, it takes this verifier, it encrypts it with SHA-256 algorithm, and encodes it with base 64 URL. So it generates a encrypted string from the actual verifier. Okay, now what happens is, when this is sent to the EHR's authorization server, okay, if you see, the code challenge is this code challenge method. It says it is this is an encryption of some random string with SHA-256 method. Okay, so now what that EHR's authorization server does is, it stores that encrypted string with itself. Okay, so now the client has the original verifier. Okay, and the authorization server has the encrypted form of it. Okay, which is encrypted with SHA-256. Okay, and it's a one-way encryption. You cannot decrypt it back until you use some brute force methods. Okay, so how it helps is, okay, and the important thing is, uh, you go to the authorization server with your client ID. Okay, this is a client ID that when you register with that authorization server, like if I register with Epic, they assign a client ID to me. So this client ID is important in this authorization request. The redirect URL. So once you're authorized, what is your callback URL? So this will be your app's callback URL. Okay, the scope means the permission. So patient star dot read means all the resources for that patient, and only read permission. Okay, and the open ID or the FHIR user. Okay, state we have spoken about. Again, it's a random UUID. Code challenge, again we have spoken about it, but I'll explain it to you in detail. I'll draw on whiteboard so that you can understand it better. Okay, and what happens now is, user logs into EHR and grants the app permission to access their data. So once they log in, okay, then the authorization happens, and the authorization server returns this auth code. Okay, remember this auth code. Now, any hacker should not get this auth code, because then he can take this auth code and uh, uh, call the API to get the token. It's not that straightforward, guys, but I'm again oversimplifying it. But to avoid that, there is a verifier, because now if you see, okay, once I get the auth code, I exchange it for token. How do I exchange it? Now it's not just the auth code that I'm sending. Now I'm sending the original code verifier that was stored in my local session when and I encrypted that with SHA 256, and now the FHIR server has the encrypted form and I have the original verifier. Now I get that auth code and I send the code verifier along with that auth code and the client ID and the redirect URI, okay, to get the access token. Okay, now I get the access token here, and then using this access token, I can, make any calls which are in my scope, in the scope defined here. So in this scope, I can make a call to any resource and I can read that resource. So using this access token now, I can get patients information, I can get their encounters, I can get anything that is there, uh, you know, yeah, the resources that are there. So this is how smart on fire works. Okay. Now let me explain you the concept of PKC, which is proof key for code exchange. Okay, this is, we are going little into detail, guys. It's important if you are implementing it. It's important for you to understand how it works. Okay, my app creates a verifier. Okay, verifier is nothing but any random string, any random value. Okay, A B C D E F 1 2 3 4 whatever. Okay, but when calling the FHIR authorization server, auth server, I'm not sending this verifier. Remember, what I'm doing is I'm encrypting it with SHA 256, this verifier, original verifier, encoding it with base 64 URL. Okay. Now this creates some other encrypted value of this original value. Okay. Anything, suppose da 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 da. Okay. And I also, so this is called as code challenge. Okay, code challenge. And there is a code challenge method that I have to send to this authorization server, because I have to tell it that this encrypted string, how I have encrypted it. So I tell it I have used SHA 256 to encrypt it. Okay. Now what does this FHIR server has? This FHIR server has my code challenge. So it will store the code challenge. Okay. And it knows that I've used the code challenge method as 256, SHA 256. Okay. Now, when I go to this authorization server, I log in with my username password. Okay. It is going to generate a auth code and redirect it back to my app. So basically, it will say after authorization is done, it will say omai.com. Okay, and it will give the auth code. Auth code equals whatever 1 2 3 4 5 6. Okay. Now remember, guys, till now I haven't got an access token. This is just the first part. I've just got the auth token. Okay. Now when it is sending me this auth token, I'm just explaining this to you so that you understand security wise. Okay, so that nobody if somebody sniffs it and if they get hold of my auth code, okay, they shouldn't be able to call the token API to get the token, because if they have the token, then again they may be able to. There are other bindings also, like the IP address and everything, which makes it practically impossible. But that's a part of you know uh, that's a part of our HTTP protocol. But this is an OAuth flow. Okay, so to avoid this, what we do is, now once you receive the auth code, okay, how the token request is made is that we will again call the from here we will call the token API, okay, and what we are going to send is now auth code, scope, client ID, and most important, now the original verifier, okay, this original verifier, not the encrypted part, because encrypted is already here with them. So when I send the original verifier, okay, now what this token API does is, it has this FHIR server has your code challenge with it. Okay, so when you send this auth code, it is not only going to check the auth code, it is also going to get this verifier. It will encrypt it with SHA 256, okay, and compare it with the one that it already has for you. And if that this comparison matches, only then it will return the access token. And now, to think about, we can think anything, that attacker can even sniff this verifier, you know when this request is going. But it's almost practically impossible, because even if they sniff this verifier, there's a TLS, they have to break that, decrypt it. Meanwhile, this verifier is already being used, and this verifier, very important security thing to remember is that it is only valid for one request. So once this verifier is used to get the token, it expires. Then this FHIR server won't recognize this verifier. Okay. Okay. And once you get the access token, now this app gets the access token. Now using this access token, it can access all the endpoints mentioned in the scope, and it can get patient's data. And then after that, you can do anything with that. So guys, I hope this entire thing is clear, because this is key part to understand smart on fire. All right, guys. So I hope this smart on fire authorization, framework, that is clear. Okay. We have seen it in detail, very detailed as possible that I can go. Okay. Uh, all right, guys. I will soon be hosting this page somewhere, and I will, post it in my YouTube channel once it is posted somewhere, so that you guys can play around with this. Okay. Uh, okay. One more thing that I want to cover is about the 21st Century Cures Act. So this is a law which mandates the healthcare providers to give patients secure access to their health information. Okay, without information blocking. And there is some important thing, because I wanted you to think. I spoke about. We did not touch a very important point, that as a patient or as a provider, if I download any FHIR app, okay, how does that FHIR app know? The smart on FHIR starts when my app knows which authorization server do I have to redirect to. Okay, but till then, how does my app know that, it's a standalone app, it's not being launched from EHR? So how does my app know uh, the actual FHIR URL? So here is where what I wanted to discuss. So ONC FHIR endpoint directory. Okay. This is a centralized directory where, so basically, imagine what you're going to do is you are going to, what Fire app, or standalone Fire app is going to do is it's going to ask you something like, hey, who's your provider? And once you enter Mayo Clinic or St. Mary's Hospital, it's going to search this directory, this endpoint, okay? And in this directory it will get all the information about that provider, including once you get the fire base URL, okay, and then you can initiate the OAuth process, and then everything goes from there. But yeah, this is an important point to remember, that there is a ONC fire endpoint directory, okay, which is a centralized directory. All right, guys, so hope you enjoyed this video. And if you're doing, or if your organization is doing anything, uh, related to fire, I would love to collaborate and hear about what you're doing, exchange ideas. Hope you guys liked the video. Thank you for watching. And if you have any questions or any comments, please leave it in the comment section. If you want to collaborate, please put a comment in the comment section, and I can give you my email address, or yeah, we can have a small chat if you're doing anything related to fire. I want to exchange ideas. I want to have a small podcast. I'd be interested in doing that. All right, guys, thank you so much once again. Have a good day. Bye bye.